Why do we have this criteria that we don't, I won't attribute it to any institution or for that matter, any person. Why is it that we are not able to understand wave in totality? There's a reason for it. And the reason is amply clear. If you focus or observe, you'll get to know reason being amply clear. Why are we not able to? Firstly, we cannot realize wave. We cannot see it happening around. It's not visible to us.
Yes.
We don't have the manifestation of it. If you don't have manifestation of anything, if you cannot view a thing, it'll be very difficult for us in figment of imagination to bring it and accordingly get a detailed study on it. So we have to first bring it into focus, what exactly we are trying to learn over here. The best example of wave, according to me, is movement of snake. Okay, it will bring waves if you're trying to be near to a snake and observe movement. That will itself generate waves in your body. So that will let you know or experience wave, as you'll be able to generate wave in your own body. You'll be hell scared and wave will move down your spine. So as wave will move down your spine, you will freeze in your spine and accordingly will be able to experience it. But I'm not talking of that experience. I'm talking of observational experience. When a wave is into propagating, then certain part is moving forward and certain part is executing motion in a particular manner. Now, what do I mean by certain part? Let's say I'm speaking and you're able to hear. So when I'm speaking, my tongue is moving back and forth. And as my tongue is moving back and forth, you can keep your hand in front of your mouth and you speak something, you will feel pressure being varied. Pressure will vary. You can feel that variation in pressure on your palm. Just speak, keep it to your mouth and speak something. Anything.
Yes.
And then see to yourself. Do you feel that there is different thrust of air which is hitting your palm? Yes or no? Just speak. First you'll have to speak, only then you'll get to know. Speak something. You'll get to see or you'll get to observe, rather. I won't say see, you'll get to observe that thrust of air is hitting your palm. Yes or no?
Yes.
That thrust of air which is hitting your palm, what is that? That is variation of pressure. Pressure is varying. You are able to vary pressure by movement of source. What is source over here? Source is tongue. And in this variation of pressure, do we require particle of medium? Yes. Wave are categorized as mechanical, non-mechanical. What are the two subdivisions for wave? A, mechanical, B, non-mechanical. Is it clear, dear?
Yes.
By mechanical, what I mean? The ones which require particle material for their propagation. Waves which require particle, medium particle for their propagation, right, dear?
Yes.
What are they called? They are called mechanical wave. Any wave which require particle medium for its propagation is called, any single wave is called mechanical wave. Clear?
Yes.
And the ones which don't require particle medium are called non-mechanical. Kuldeep, are you recording? Recording, right, dear?
Yes, sir.
So the ones which require, I repeat, waves are broadly classified as mechanical, non-mechanical. Clear? Ones which require particle medium for its propagation, they are called mechanical. The ones which don't are called non-mechanical. In our study for ITJ preparation or preparatory course entails only mechanical wave. Remember that. You don't go for non-mechanical wave. ITJ preparatory course includes or incorporates, embodies only one kind of wave, and they be mechanical waves, the one which will require particle medium for its propagation. we'll limit our study vis-a-vis ITJ preparatory course to mechanical waves. Clear? Okay.
Yes.
Now, mechanical as well can be classified as A or subdivide as A transverse, B longitudinal. Clear, dear? Mechanical per se can be subdivided as A transverse and B,
Longitudinal.
do you say longitudinal? Can you get me a distinction between transverse and longitudinal? Can we distinguish?
In
Can we distinguish between transverse and longitudinal?
in transverse waves, the direction of propagation of waves is perpendicular to the direction of movement of the particles or the
Correct.
vibration of particles. In longitudinal waves, they are along the same line.
Exactly, isn't it? What, Viva? Is it clear, Viva? In transverse wave particles, particles of what? Asset Kuldeep. In transverse wave, Asset Kuldeep. In transverse wave, particle of medium will execute their motion perpendicular to propagation of wave, and in longitudinal, it will be the direction of propagation of wave. Okay, dear, in longitudinal, it will be in the direction of propagation of wave. Mind you, particles don't move in bulk. It is not that particles are moving. Best example is being cited by S.C. Verma. He says that let there be 10 people standing in a queue. Let there be 10 persons standing in a queue. And a person who is at 8th position or 9th, 7th, 6th, whichever it may be. A person, let's say, who is at 5th position pushes the person who is at 4th position. Is it okay? Person who is at 5th position pushes the person who is at which position? 4th position. Fine. Now, the person who is at 4th position, if he appreciates the push, he will acknowledge it. He is acknowledging the push, let us say. So if he is acknowledging the push, then what will happen? He'll respond to it. If the person who is at 8th or 4th position, as I'm at 5th position, I'm pushing. So the person who is at 4th position, if he acknowledges, if they acknowledge the push, if they, why? Because I don't know the gender. So if they acknowledge the push, then what will that person do? That person will reciprocate, correct?
Yes.
So maybe that person will bend forward, will apply to that force. He will accept it. Then he will bend forward. Or if he is not into acceptance, what the person is to come back to me with, he will say, you push me with whatever might you do have in your capacity. I'm not to bend. I will be unmoved. I'll be undeterred. These are the two responses I can cater, right? Yeah. One, okay, I reciprocate and I accept, accordingly will bend to your need. Else, I am not to relate to you anyway and will not move, will be unscathed, immune to your push. I'm alien to your push, right? Am I clear?
Yes.
Now, there are two scenarios which you may get. First case, reciprocation did take place. So what happened to the push, the energy which I did provide? What happened to the push? I wanted to push the person who was at 4th position. I was able to apply force. I pushed him, but that push is not limited to person concerned. What will that person do? It will transfer the state, correct? Think about it. I disturbed the person's state. The person who was at 4th position was disturbed by me. I've disturbed his state. I've disturbed their state, right? I have disturbed their state. Say yes or no?
Yes.
I have disturbed their state. Now, what will happen? Will that person keep the state to himself? They will try to reinstate, no doubt about it. He will try to get back to the state that he was in before of my push. But in the due course, what that person does, he'll let the state transfer to the person who's at 3rd position. It will then go to the 2nd position, then to the forefront, correct? Yes or no, Vibha?
Yes, sir.
So
Yes,
tell
sir.
me, dear, what happened? What did happen? The energy, the state got transferred. Can I say? Energy, I did work. It got transferred. State got transferred. Correct? The
Yes.
disturbed state of fourth position person got transferred to third, then to second, then to first. Please mind class. Here, what is happening is transfer of energy is taking place. You will uptick it, yes. Transfer of state is taking place. You will uptick it, yes. Semi yes or no. Transfer
Yes.
of state is taking place. Transfer of energy also is taking place. But for
Yes,
this
sir.
transfer, what was required? Kuldeep, tell me. For this transfer, had the person be rigid, had the person be not relatable, when you'll be rigid to other guy, when you're not related to, right?
Yes.
Say a candid no to any person. Can you say a blatant no to your mother? Can you say an abject no to a person you are related to? Even if you have dissent, let's say you disagree with the person, you will not going hurting that person by being blatant to or being in face no. Will you? No, you will not.
No.
If at all you are to say no, you will sugarcoat it, correct? You
Yes.
sugar. Why? Because you're related to that person. Relation brings flexibility. So if the person who are in queue, if they were related to each other, if the person who is at fourth position were related to me,
Mm.
then the person would have responded to my force, correct?
Yes.
The person would have been flexible. If not related, rather it'll backfire, it'll boomerang, right?
Yes.
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 So
Yes,
when
sir.
you're related, you're flexible. And when you're flexible, then in physics terminology, we call it elasticity. In the terminology of physics, flexibility, or in science term, flexibility is termed as elasticity. Why I'm coining this term, elasticity? Because certain part is not taken in classes. I want to highlight those parts. Elasticity. Elasticity is the prerequisite for transverse wave communication. Elasticity is the prerequisite for transverse wave communication. Transverse wave cannot communicate. Transverse wave cannot propagate if the system in which I'm trying to establish it is inelastic, not possible. So for propagation of transverse wave in a medium should be elastic. Now by elastic, what I mean, that also I have clarified. If not, please write it down in so many words. By elastic, I mean people. What did I say about people? Tell me. What did I say? Should be related to each other, right?
Yes, sir.
Person in queue must have some relation with the other person standing in the queue. So they are related to each other. Therefore, they are in which medium? They are in a medium of flexibility. And flexibility is what termed as elasticity. So that medium is what we are celebrating. Which medium? Medium flexibility. So if you are related, if the particles of a medium are related to each other, then that medium is called in physics terminology elastic. Got it here?
Yes.
And if
Yes.
the medium is elastic, only is possible then to generate wave, which we are categorizing transverse. Mind you, the caveat is only for transverse. There is no rider for longitudinal.
Mm.
Longitudinal you can establish. So there is no prerequisite as such, whereas the medium is concerned. Of course, there should be medium, and we are dealing with only mechanical waves. So all the waves which we'll be dealing with, they will be propagating in a medium. There being no caveat means there is no prerequisite for establishment of longitudinal wave. Clear, dear? No
Yes.
prerequisite for establishment of longitudinal wave. Yes, certainly we do have for establishment of which wave? Transverse. And what that being, dear? That being that medium should be elastic.
Elastic.
It must be elastic. Yes, Bibha, you're asking
So
something. Yeah.
the longitudinal waves can be in inelastic medium and elastic medium, like you're saying. So like the
Yes,
it's
dear.
like everywhere.
Longitudinal
It's
wave,
everywhere.
right. But there is no rider. By the way, Vibha, by elastic or non-elastic, what do we mean? We mean that particles are inelastic, related to each other, and in inelastic medium, particles are not related to each other. S.C. Verma asked a very important question over here. You know what he asked? He asked, in gaseous system, which wave is possible? Only elastic, only inelastic, both elastic, inelastic. What will you say? In a gaseous system, which wave, according to you, is possible? Yes, Vibha.
Okay. So in gaseous system, the particles are at a distance with each other, so they are not related. No, they're not related. So the longitudinal waves can be there, sir, because we're in inelastic medium.
Okay. Do you subscribe, Kuldeep, to what she has said? Do you subscribe to her?
So no.
No, you don't. Okay. What do you hear? Tell me, what is your thought?
So I think because there are many particles in a gaseous medium and they are all closely related, possibly.
In
Yes, sir.
gaseous system, Kuldeep, one particle has got nothing to do with the other particle. They are free particle in a way, right? That's the reason they move very fast and fill any space. If you're spraying in the corner, it'll fill any space in no time. So there is no relation between two particles.
Okay.
And if there is no relation between two particles, what system, what medium we are referring to? As said Vibha rightly so. Yes, Vibha, tell me what medium we are referring to. A medium in which there is no relativity. Right, dear? There's no relation they share. And if there is
Yes,
no
sir.
relation they are sharing, that the medium on physics terminology will be called which medium, elastic or inelastic?
Inelastic.
Inelastic.
So the only wave possible to get established in that medium will therefore be longitudinal. Will not be able to establish transverse wave in gaseous system. Can I shift my focus to bulk of liquid? Let's say a river is in flow and I'm not on the surface of river. I have taken a dip and I'm within the river, within the surface of river. If it is so, I'm limited to within the surface. Somehow I'm managing to be there. I have a cylinder, oxygen cylinder, and I'm managing to be there. And I'm trying to establish wave inside of it. Okay. What wave is possible to get established there? Yet again, what wave? You're talking of fluid, right here?
Inelastic.
Yet again, what wave? The only wave which I can establish there will be longitudinal. If I'm on surface, then if I'm trying to establish wave on the surface of fluid, yes, please tell me. Surface of fluid, what will it be? Surface, can you tell me? Well, we have surface of fluid, not in the bulk of fluid. I'm on the surface of fluid now. So is it possible for me to establish? I won't ask longitudinal, it is anyway possible. Is it possible for me to establish transverse there? What say you, Vibha?
Yes, sir. It is possible to establish a transverse waves because when we are set in the motion of waves, we can see that they're moving in the wave is moving in a straight line and everything, and we can also see the ripples of water. For example, we can also see the ripples of water. So, like that.
Okay. Okay, that's good. You are letting me know the anecdotal evidences. We do see ripples. You're absolutely correct on that. But I wanted to relate it to what we studied a few minutes ago. If you are to profess or advocate that yes, you can, then you will have to, in the same breath, admit, right? What will you have to admit? In the same breath, you will have to admit that particles are related to each other. Only then you can establish that the surface is flexible, that the surface is elastic in nature. Elastic means particles are related to each other. So how can you say that the particles are related to each other on surface? Are they related to each other or not? Is the first question. Are they related to each other? Are the particles related to each other on surface of, let's say, water? What
Yes,
say?
yes, sir. Yes, sir, because it's
Yes,
water.
yeah.
The liquid molecules have attraction like that. Yes, sir, like that.
No, that was there. See, liquid molecule, if you are saying will have attraction, then that was even there in the bulk, dear. In the
Yes,
bulk when I was, then also I was dealing with liquid, and there also the same attraction will work.
yes.
But that didn't help me. That didn't help me in establishing transverse wave.
Okay.
So that's not the reason. The reason out here is, yeah, we have seen, we have observed, so we cannot negate. We cannot be in odds with what we have observed, isn't it? We cannot live in denial. Of course, we are able to. And why we are able to, better reason, science depends on how the things are into progressing. We have to reason it out. And accordingly, try to make better models. So what we are trying to do over here, we are trying to analyze it. Why? How is it possible here? I'm not able to generate in bulk, but I'm able to generate on surface. How is it possible? Of course possible. Why? Phenomena surface tension. Phenomena surface tension. What will surface tension do? How will surface tension come to my rescue? I'm finding refuge in surface tension. I'm finding refuge in surface tension. Why? Because surface tension is the phenomena which will relate particles on surface. It's surface phenomena. The same cannot be in any way observed in the bulk. If I take a dip, if I take a plunge. Right, dear? But on surface, they are related. Which phenomena? Surface tension. Particles are related to each other owing to surface tension, and that serves my case. That serves my case. Particles are related, therefore surface is a different story altogether. Yes or no?
Yes, sir.
Surface you will be able to generate transverse, not in bulk. On surface, we'll be able to generate transverse wave, not in bulk. In the bulk, beneath the surface, I will not be able to generate. On the surface, I'll be able to generate. And that's exactly what Vibha was indicative of, that when we see ripples. By the way, let me tell you that ripples which you are into observing is an amalgamation of transverse as well as longitudinal wave. Okay, it's not just transverse, or certainly cannot be just longitudinal. So it is a combination of transverse wave and longitudinal wave. Why do I say so? Place a cork. Okay, place a cork and drop a pebble. You will generate ripples, correct? Had it been only transverse wave, cork would have moved up and down its position, correct? Because what will cork represent? The motion of cork will be a replication of motion of particles of medium. What is the medium over here? Water, correct? Every particle, every single particle is manifested by motion of cork. Okay, dear? As the cork is to move, particles of medium are to move. How will it move? How will the cork move? Up and down. So every particle is, every single particle is up and down its position. Had it been only transverse wave, in solo transverse wave, unilaterally the transverse, then cork would not have moved towards the brim. It would have in its position moved up and down. Practically, what you see, what you'll get to see, you'll see for yourself. Just take a small quadrant and put up, just place a cork, drop pebble. You'll get to see that not only cork will move up and down, it will also move outwards. Okay, it'll move outwards. It'll try to come to the bank of pond or whichever place you are in. It'll try to come to the brim of cauldron that you have taken. Okay, dear?
Yes.
So it's a combination of transverse and longitudinal. If it's pure transverse, then cork will not move horizontally. It'll move only in the vertical direction. Okay, dear? It is manifesting particle of medium, so it'll move in the vertical direction. Is it okay, Vibha?
Yes, sir. Can I just see? So in transverse wave, the cork will move up and down. No movement along the horizontal direction. Longitudinal only movement up and down, and along with it, it will move downwards.
Longitudinal, I didn't say because it's moving outward. Moving outward doesn't mean it is longitudinal. I said, had it been transferred, it would have remained at its position. X would not have changed. Only Y would have changed. Okay. But practically, when we get into this experimentation, we find X also to change. So it's a combination. This wave is a combination. I will cite examples. Ripples, we will not be taking longitudinal. When I am to cite example for transverse, I'll be assuming. Are you getting it? Assumption is different from practicality. I'll be ideating it. So what will I say? I will say ripples. And ripples will then be studied as only transverse wave. But remember, in actuality, it is transverse plus longitudinal. If it is transverse, only transverse, then the particle or the cork will move only up and down. It will not move outwards. Okay?
So then what about longitudinal? If you just take a case of fluid where longitudinal waves are there, how do we distinguish it like that?
Firstly, longitudinal comes, as I've told you, longitudinal wave, any longitudinal wave comes with no rider. You can establish longitudinal wave anywhere. So there's no rider over there. Okay, dear? The only differential, as Kuldeep did cite, is in the motion of particle. As the ripple moves out, how will the cork move up and down? Let us say now that the wave is completely transverse, only transverse. So as the ripples are moving outwards, ripples are spiraling out. If the ripples are spiraling out, what will happen to the motion of cork? It will move at its place up and down, right?
Yes, sir.
So disturbance is moving out. But the particles of medium, they are not moving with disturbance. They are at their position, executing motion. In which direction? Perpendicular to propagation of wave, correct?
Yes.
Yes, sir.
So what example is this? This will be example cited for which wave? Transverse wave. And if I'm speaking, I'm disturbing particle, right? How? My tongue is moving back and forth. So how is the particle getting disturbed? This way, right? This way. And how is the wave propagating? In this direction only, correct?
Yes.
So particles are executing their motion this way, and wave is propagating in the same direction, correct? Or along the same line. I should not say same direction, along the same line, correct? So this is an example of which wave? This is an example of longitudinal. Okay, dear?
Yes.
Yes, sir.
Now, another example which we can cite for transverse wave. Let us take a rope, tied to one end of the wall, and the other end is being held by me. Okay? There's a rope, imaginary rope tied to one end wall, and the other end held by me. What I do? I give it a jerk. I move my hand up and then down. Up and back to the position from where I began. Okay, dear? Up, back to the position from where I began. Okay? Clear?
Yes.
What happened is an obvious. You must have experienced. A bump, a hump will get generated. A hump will get generated. And that hump, stay put there? Will it stay put there? No, it will not stay put there, right? What happened to the hump? It will move. You must keep the string or rope taut. Okay? Holding it tightly. The string is stout, and then you give a jerk. What will happen? Bump being generated, and the bump is now propagated. It will move forward, right? As you move your finger up and down, what is this an example of? Example of what? Particle of medium. What is the medium over here? Rope.
Yes.
So your hand is doing particle of rope, moving up and then down. Bump got generated. This disturbance will not limit over here. What will happen to this disturbance? This disturbance is to propagate. So the disturbance now will move forward. It will move from your hand particle to a different particle. It is propagating in a similar manner. How did the energy propagated in the Q? Correct, dear?
Mm.
The state of motion propagated, right, in the Q. So
Yeah.
what will happen over here? Energy and state of motion will get propagated. It is moving. It is moving. It will keep on moving. So that bump, what will it try to do? I have taken this scenario. Here is, let's say, wall. I have generated a bump over here. Okay. Now, as the bump is progressing, what will it try to do? It will try to lift the points coming in its way. Yes or no?
Yes.
It will try to lift the points coming in its way. Yes or no? So it is trying to lift the points coming in its way. Now it reaches wall. Here is the wall. What will it try to do? It will try to lift this as well. Will it be able to lift it? No,
No.
it will not be able to lift it. Why? Because wall will oppose it. Wall will oppose it. Wall will apply force in which direction? Downward direction. Wall will apply a force in which direction? Downward direction. Opposite, you're right, Viva. In the downward direction. The string is trying to pull it upwards, this point upwards, and wall is trying to pull this point downwards. Push this point downwards. Is it not akin to a person standing there? Remove wall. Think that there's a person standing there. What the person is trying to do? They are trying to move it down. Applying force, right? The person will apply force. He is to do a wall there, correct? The person is to do a wall there. So what the person is into doing? The person should apply force akin to what the wall is into doing. Wall is applying a force in downward direction. So person is standing here. What will he do? What will that person do? What will they do? They will apply force in which direction? You have removed wall now. They will apply force in which direction? Downward direction. So it is not the person doing a source. The person is doing a source, correct? It's trying to be a source. Source to string. Applying force in which direction? Downward direction. What will happen now? That person will generate wave. As this will go in, this will come out, right? If you are assuming that there is no loss of energy only then, amplitude will remain intact, shape will remain intact, subject to no loss on energy. So this will go in. Yes, dear. Yes, Viva. Yes, Viva.
So this is like in accordance with the third law of motion, like that. Like third law of motion, like like opposite. We put a force on a body, like third law of motion, opposite, equal and opposite.
Just think about this, Viva. If I would have moved my finger down, if I would have applied force in the downward direction, then what would be the shape of pulse? Inversion?
Yes, sir.
Shape of pulse would have been inversion, right? As I moved my finger up, I got this shape. If I would have moved my finger down to begin with, I would have got an inversion, right?
So it's in accordance with the third law of motion, sir. Yes, sir.
Yeah.
Okay, sir.
This person
Yes, sir.
is trying to move it down, right? This person is trying to move it down. So move it
Yes,
down
sir.
means what will it shape to? It has not shaped as yet. For it to shape, it will take time, right? For this also to shape, it took time. I moved up, then down, and then it got shaped, correct? This
Yes, sir.
person as now applies, now he applies, that person, now they apply Force in which direction? Downward direction. It is not shaped as yet. It is beginning to shape. Are you getting it?
Yes, sir. Okay, sir.
But I'm not showing it this side. I'm not showing it this side. I'm showing it beyond the wall, right? After of the wall.
Yes.
Yes.
Now what is happening? Yes, this is going in and energy intact. This is coming out and they are at same pace. One
Yes.
going in, the other coming up. After some time, what will happen? What will be the shape after some time? I want to break it into last set of dissection. Therefore, I'm going bit by bit. What will be the shape after some time? This will go in, this will come out, correct? Let's say 10% of this goes in, 10% of this will come out, correct?
Mm.
Which area will be more? Up area or down area? Of course, up area, correct? So what will I get? I'll get a diminished one, but area upwards, correct?
Mm.
Getting it or not? This went in, this went out, but 80% of this is out, right? Or 90% of this is out, and only 10% of this is out, correct? So which will dominate? This side will dominate. So it will be distorted. It will be less on area, less by what percentage? 10%, but shape will be upwards. It will remain upwards, right, dear?
Yes.
Let's say 50% got in, 50% came out. Then half went in, half came out. What now? What will be the structure? What will be the shape you will be able to see?
E.
Half went in, half is out. You will get a straight line. Idea?
Mm.
Half of this is in, 50%. Half of this is out, 50%. 50 up, 50 down, flat.
Mm.
Now, which is dominate thereafter? Tell me which will dominate.
Downward.
Thereafter, which will dominate. This will be out, let us say 90%, and this will be in 90%. So, which will dominate? The lower one.
Downward one.
So, you can get the intermediate shapes. One will be this way, because this point will not change. The other will be this way, right?
Mm.
Getting it?
Yes.
And then finally, it will eventuate to what shape? This shape. Are you getting it?
Okay.
So what happened in due course of reflection? Can you tell me? This is what is called reflection. In the due course of reflection, what has happened? Inversion of phase.
Mm.
There's a phase difference of pi between incident and reflected. Phase difference of how much? Incident is this, reflected is this. The phase difference of pi between incident and reflected.
Mm.
When is this difference possible? When the wave is reflected by relatively denser medium.
Mm.
When the wave is reflected by which medium? Wall over here, right? The other medium was wall, correct?
Yes.
We are talking of media over here. Medium 1, rope. Medium 2, wall. So the media over here. Media is the plural for medium. Okay, dear? So the media over here accordingly being taken. Fine?
Mm.
So which medium is denser over here? Wall certainly is assumed to be denser than what material? Rope is made up of, or medium rope. Correct?
Mm.
So when it's getting reflected, which wave? Transverse wave. Now another point which is not taken in classes. This is true only for transverse wave. What that being? When a transverse wave is reflected by relatively denser medium, then there is a phase change of pi, not longitudinal. Please highlight it, underscore it. Not longitudinal. Longitudinal wave will behave in exact opposition to transverse wave. By that, what I mean, if longitudinal wave is reflected by relatively denser medium, then there is zero phase difference. Assertive on it, as is not taken. Then there is zero phase difference between incident and reflected. Which case? When longitudinal wave is reflected by relatively denser medium. And that is obvious. Tell me, why did I say so? Why is that this obvious? Let's say I am sending this wall a compression. Okay, any surface. This is the surface. Palm is the surface. I'm sending a compression to it. What will I get? Wall will apply force in the opposite direction. So I am hitting the wall this way, right? With a compression. So wall will hit will equal force in the backward direction. So what will I get? I'll get a compression. If I'm hitting it lightly, what will the wall do? Wall will get me a lighter force. So compression will result in compression. A rarefaction will result in rarefaction, right? Yeah.
Yes.
That's the reason longitudinal wave, when reflected by relatively denser medium, phase difference between incident and reflected is of 0. There is no phase difference.
Okay.
Which is in opposition to which wave? Transverse. Okay, dear?
Yes.
Okay. So till now we were buttressing or advocating for wave means what? Wave means disturbance in progress, energy in progress, state of motion in progress. Can we say that? Wave means energy in progress, state of motion in progress, right? Yes, state will keep on changing. So state in progress, correct? Correct. I ask you a question. You must have studied about standing wave. Why do we call it a wave? There's no energy in progress there. Energy doesn't propagate in standing wave. State of motion doesn't propagate. They are limited to position. Right? Standing wave, plugging a guitar string. Standing wave generated. State is not propagating. Energy is not propagating. What is antinode will remain antinode. What is node will remain node. Node will not change to antinode, right?
Yes.
So what about the motion? The motion will be at the same place.
Motion will be
motion.
Whichever is moving with A amplitude will keep on moving with A. Whichever moving with A by 2 will keep on moving with A by 2. Whichever moving is 0 will keep on having 0. That depends on which mode it is vibrating. Fundamental mode, second harmonic, third harmonic. We'll study about it in detail. But my question over here is, why do we call wave? Why will we give an epithet to something which is not advocating or which is not exhibiting propagation or transfer? There is no transformation. There is no transfer. There is no propagation. It doesn't exhibit. It doesn't cut ice. It doesn't occur well to us. But still, we are into associating the epithet. That is what the contention with Mike is. Actually, Zil, why I am associating the epithet wave? Why don't you say standing something else? Why wave? It still qualifies to be called a wave, right? Yeah. So here is the paradox. And here we digress from the idea of energy. So it has nothing to do with energy, is what I'll bring forward. It has got nothing to do with state of motion. They are the byproduct. Nothing to do with energy, nothing to do with state of motion. What it is to do is only one equation. And what that equation, you know, that equation is Maxwell's equation or Wave's equation. What is that equation? Maxwell's equation or wave equation. So if any mathematical equation is given to you, if it can be written in the form of Maxwell equation solution, if it can be shaped as solution of Maxwell equation, then that mathematical equation represents wave. Then that mathematical equation represents wave. Is it okay? Am I clear on that front? And just to begin with, in class, what we say, any equation y is equal to f of x minus vt, function of vt, isn't it? This represents wave. It should be bound. It should be bound. By bound, what I mean, it should not take infinite. Any mathematical equation of the form x plus minus vt is what we say in general. That is what is being in class professed. What we profess in class, any equation which is function of x plus minus vt and is bound will qualify to be called wave equation or present a wave. For example, if I ask E x raised to power minus, is this a wave? No, it is not. Why? Because it's not bound. It can take infinite value. Similarly, I asked one e raised to power x minus vt. Is this a wave equation? No, this also is not. Why? Because this can also take infinite value. Suppose x minus vt is infinity. So e raised to power infinity. Suppose x minus vt is minus infinity. Again, e raised to power infinity, correct? Then I ask, okay, what about this one? Ex minus vt, the mod of it. Now you will say, yes, it can. Why? Because it cannot take negative value. So it cannot go to 0 is not a contention, mind you. Contention is infinity. 0 it can take. 0 is not a contention. 0 is defined. Infinity is not defined, so it cannot take infinity. Why? Because then energy will be infinite. So we begin with that a wave means x minus vt, x plus vt, function of it, and it should be bound. By bound, what I mean, energy should be contained. It cannot take infinite value of energy. Okay, dear? That is what we profess. And then what we do, we differentiate. And what will be differentiation of it? F. I'm differentiating partially with respect to f x minus vt into 1, correct? Then y again with respect to x double bar x minus vt into 1, correct? Now we differentiate it afresh with time. What will it be? F x minus vt into minus v, correct? d2i dt square, what will this be? F double bar x minus vt into v square, correct? Minus v square, correct?
Yes.
Okay, now you're having two equations. This is 2, this is 1. Divide them, you get wave equation. That is what is called Maxwell equation. Okay, wave equation. If you can divide, you will get a wave equation. See for yourself what will it read. D square y dx square. What is it equal to? From where you can say you can remove it by this one. So v square into d2i. We call it d2 dt square. Check it out here. Right? What is this wave equation? This is what is called Maxwell's equation. And there are as many as 12 solutions for this Maxwell equation. How do we write Maxwell equation solution? F x plus minus vt plus minus g x plus minus vt. This is how we write solution. Okay, dear, Maxwell equation solution. Fine?
Yes, sir.
Now, if I ask 2a sine kx cos omega t, this you will get to know is the standing wave equation. But how do we come to this? We take one wave a sine of the angle kx minus omega t and the other wave plus a sine of the angle kx plus omega t. Okay, dear? And we combine to get this. We combine them to get this one. Mathematically, you can very well justify it, right? Sin a plus b, sin a minus b, when added, you will be getting this. Now, this is nothing but one of the solutions, right? F x minus vt and plus f x plus vt, right? So, one of the 12 solution of Maxwell. That's the reason it is called waves. That is why we
Yes,
call
sir.
it wave. So wave is related to Maxwell. If I can present any mathematical equation in this form, I'm not going by energy, I'm not going by state of motion, I'll say yes, it is a wave. Okay, in wave, we have change in position and also propagation of wave, propagation of disturbance. It propagates. That is called progressive wave. If it is not propagating, then you are not to call it progressive. You have to call it wave, which is static. It's not moving. Yet will be called wave because this is one of the solution. It can be represented by one of the Maxwell's solution. Clear, dear?
Yes.
Yes,
Am
sir.
I clear on this front?
Yes.
Both of you?
Yes.
Yes, sir.
Okay. Yeah, so this is about initials of wave. How do we go wrong? Why do we go wrong? We start with that, and that is not the way to start. Way of start is different, completely different. First part of the wave. We just understand what wave is. We are aware of it now. When wave propagates, what can change? A wave is propagating. You take a snapshot. So what are you freezing? You're freezing time. Okay, when a wave, you have to see that wave when it's propagating, then there are two factors which will change. What will change? Y will change with respect to X and Y will change with respect to time. This amalgamation also is difficult for us to decode because we are not able to see them in isolation. I want to see them in isolation. See, wave is propagating and I said that, okay, wave is propagating means Y will vary with X and Y will vary with time as well. But I want to see them in solo, in isolation. So I want to see variation of Y with X, let us say. What will I have to freeze? I'll have to freeze time. How can I freeze time? By taking a snapshot. So a wave was, this is a snapshot, correct? This is a snapshot. Wave is propagating. What do I do? I have frozen it. Frozen in time, correct? This is a snapshot, yes or no, Vibha?
Yes, sir.
And in this
Yes,
snapshot,
sir.
you can see Y varying with X. Can we say that? Y is varying with X. Yes or no?
Yes, sir.
Right here, Kuldeep?
Yes, sir.
Y is varying with X. So this is solo variation. You can see over here. You have frozen time. We are frozen in time. So we can see, okay, I took a snapshot. I did freeze time. So what I'm to see in solo, how is Y varying with X, correct?
Yes, sir.
Now you may ask, okay, I don't want to freeze time. I want to freeze X. I want to freeze X and then see how is Y varying with
Time.
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 So for that, what do? You assume this line, X, constant X, correct?
Mm.
X is constant now, correct?
Mm.
Where is this
Okay.
particle here? Check it out. Where is this particle at the top, correct? Is not that particle at the top? The particle which I'm highlighting, this one. Can you see this particle?
Mm.
Here, correct?
Yes.
Yes, sir.
Now let the wave move. Wave has moved. I'm showing you now this way. Let me show it right. This is my wave. Okay, dear?
Mm.
I'm over here, correct?
Yes.
This particle. I have taken this position.
Mm.
After some time, what will happen? This shape will move forward.
Mm.
So this has come here, this has come here. I join them. Okay.
Mm.
What happened to this particle? It came over here. Then what will happen to it? It will go further up. So look at this particle. You have frozen X. X is equal to, let's say, X1. How is the particle moving on this line? Up and down with advent of time. Yes or no?
Mm.
Yes, sir.
So this is solo. How is Y varying with time? You saw in solo how is Y varying with X. Now we are in solo. How is Y varying with time? And then when they are amalgamated, when there are some superimposed, then we get equation of wave. Equation of wave means y as a function of x and time. Okay, dear?
Mm.
Y as a function of x and time. And why do we have x minus vt? Is also very simple. Quickly on that. What is that function that we speak about? X minus vt, what exactly it is? Very simple. If you have this to be represented in mathematics, this one, and you say that this is y is equal to fx. Now, if it moves forward by certain distance, what distance? By distance, let us say b. Then how will you represent the new one? You will represent the new one as y is equal to fx minus b, correct?
Mm.
And v over here, constant velocity time t. Let's say we were going with constant velocity v and we observe for the time t. Then what we can write it as y is equal to f x minus vt, correct?
Yes.
So forward x minus vt and backward x plus vt.
Plus VT.
So any equation that you have got, if it has got, for example, equation that you have got is a sine omega t. Suppose this is the equation. Okay, this variation in time, correct?
Mm.
What will I do now? I want to make it progressive. So what will I do? A sine of the angle omega t minus t prime, correct?
Mm.
Yes,
Because
sir.
function of time t minus t prime. In t prime, what distance will I move x with what speed v? So what will be t prime? X by v,
Yes, sir.
correct? So what do we write it as? Rewrite it as a sine of the angle omega t minus x by v, correct?
Yes, sir.
This is what to shape a sine of the angle omega t minus omega v into x.
Mm.
And then we have customary to write omega by v as k. What the equation? A sine of the angle omega t minus kx. Where what is k? K is a representation for omega by v.
Mm.
By the way, be very mindful of this fact that this is equation not in vector form. This is equation in what form? In a form of a particular direction. And k, what do we call, is also a misnomer. Over we call over here k is called propagation constant, but actually this k is a vector. This is called wave vector. This k is called wave vector. Quickly into writing that down. This is omega t. Just quick reference to it, very important. Again, not taken. This comes from one of the question which is there in IE. How do we get to theory? How do we extrapolate? See, we have to extrapolate theory from that book. How do we extrapolate that question? You know, asked that okay, this is y-axis, this is x-axis. A wave is propagating in this direction, making an angle theta. Write equation for it. Now, so far as direction naming is concerned, if you mark it as R, then you can write, okay, A sine of the angle omega t minus KR, right? We can.
Mm.
Yes, sir.
But R has got over here no significance. He has asked to present it in X and Y. R no significance. Then what we do? How we present in X and Y? We know about rotation of axis in mathematics. Okay, we are aware of rotation of axis in mathematics. I presume you must be known to it.
Yes.
So this is, let us say, my x prime. This axis is which prime? X prime axis. And this is which axis? Y prime axis. Okay, dear? So x prime mathematically can be written as x cos theta plus y sin theta. Are you in agreement with this?
Yes.
Aware of rotation of axis? What do we get to see then? Okay, a sine, I'm not allowed to write r. So omega t minus x cos theta, right?
Mm.
K as it is. And then minus, again, k as it is. Y sine theta. Do check. Do check, dear. Is it okay, Beba, Kuldeep?
Yes.
Now, K is a sign vector terminology. And if K is vector, then what will be K cos theta? Of K vector, correct? X component of K vector will be K cos theta and Y component will be K sin theta, right, Vibha?
Yes, sir.
Okay. A sine of the angle omega t minus kx. Kx into x minus ky into y. Can you check it there?
Hmm.
What can we then write it or rewrite it to be is a sine of the angle omega t minus k dot r. Check now. K dot r. Where what is k? Where what is k? Kx I cap plus ky j cap. We are in plane, so I'm not writing the z1. And what is r? R is xi cap plus y j cap. Getting it?
Yes.
Yes,
This
sir.
is how you present wave equation in vector form. Vector form. Now you will write it as y or zeta is the symbol that they use. Zeta is nothing but y, you may assume, but y means only one direction. It can be any direction perpendicular to wave. Therefore, to incorporate all the direction, what we do, we take zeta. Okay, dear? It's not necessary to be y direction. Any direction perpendicular to x means this direction, this direction. They are all perpendicular, correct?
Yes, sir.
So to incorporate all, what we use a symbol zeta. Zeta as a function of r and time. Vector equation for wave. This is the one. A sine of the angle omega t minus k dot r. Here k is called wave vector. What is k called? Wave vector. Let's say wave is propagating in x direction. What will be theta? 0.
0.
Is theta 0 here? This becomes 0.
Ky 0.
You will be left with kx. Then you will get omega t minus kx. Correct?
Mm.
That is what we study, omega t minus kx. But this is what to us? Vector relation. Am I clear on vector relation? This one?
Yes.
Yes, sir.
This is wave equation. Now, quickly into till the time the device is the device is going off now, 15% only. Okay. So I was to take Doppler's effect and beats. Both are very important. They are interference. Both are in cases of interference in a way. If I'm talking of beats, it is interference in time. If I talk of interference, general interference is misunderstood as interference in space. So one is interference in space, which we study. The other that we miss in classes is interference in time, which is what is called beats. So beats are not taken. I'm aware of it. I'll be taking in detail beats, what they are, and you'll get to know everything about beat. That will also help you in communication system later, in understanding of communication system later, the modulation, amplitude modulation. So beats will be taking in detail, and we'll be also referring to what is special about Doppler effects in light. Questions being asked. Doppler effect in sound, okay, but Doppler effect is a wave phenomena and light being wave. How do we incorporate Doppler effect in wave, electromagnetic wave? We'll be going into that, but before of that, we are to study for Doppler effect in sound, longitudinal wave. Very important. Doppler effect is good till the time you have constant velocity. If you have variable velocity, then how will you plot for Doppler effect is what you have to check. For a quick relook, can you tell me Doppler effect? Can you draw frequency versus time plot if a train is moving on a track without stopping? It is whistling, it is moving on a track, it approaches source. Source means over here the recorder. It approaches recorder and leaves the recorder. Can you draw frequency versus time graph? versus time as recorded by a device which is kept on the track. Train doesn't stop. Train is moving with constant speed. Frequency versus time. How's it? Lydia?
1 minute.
Okay. Vibha, are you through?
No, sir. I'm just trying to figure out. I'm just trying to see. Sir, frequency will be inversely proportional to time, right, sir?
I don't know. I'm asking first. I'll come to that later. Kuldeep, can you show me a drawing, dear, quickly? It'll drain off, dear. I say less one 15% long back. Quick. I have not put it on charge. Only when I take class, I place it on charge. Today I missed. Kuldeep, please share with me the video later, okay?
Yes, I'll share. So I'm not able to plot the exact one, but I think it'll be kind of hyperbolic with two asymptotes.
It'll be this, dear. It'll not be hyperbolic. Hyperbolic is a hyperbole. It'll not be hyperbolic. Why will it be this? What is frequency? V, when the train source is at rest, source is moving, right? So observer is at rest, so V naught 0. V minus Vs, correct? When it's approaching, correct? Constant, it's not changing with time. And when it's receding, then V plus observer is at rest, so you can mark, and V plus Vs, right? That's it. This one, and then drops, and then this straight. Okay, velocity constant, correct? What if train is accelerating? How do we get? What happens, when source is moving, then what changes? Remember this very important point. When observer moves, then relative velocity changes. When source moves, then changes wavelength. When source moves, then changes what? Wavelength. When observer moves, wavelength doesn't change. See, tuning fork kept over here. It is producing one compression C1. It is producing another compression C0. Observer over here. Okay, it starts running with V0 speed. Now tuning fork over here. It is producing, let us say, C2. I'm showing compression by one line. It is not one line, you are aware of it. See, where is C1? C1 is over here. What is this distance? Lambda, correct? This distance, lambda, correct? Right?
Yes.
Now source started moving. Source is running. How will I write frequency first? Frequency will be written as V by lambda. You are aware of it, correct? V the speed of sound. Now source started moving. Sorry, observer started moving. With what speed? V0. So what will be the new frequency? V plus V0, right? V plus V0. V this way, V0 this way, so they will add, right? V this way, V0 this way, they are in opposite direction, they will add. So V plus V0 and lambda remains. Lambda same. Now what we write? V plus V0 and plus V0 and lambda can be represented by V into tau. What is lambda? V the speed into tau. What is tau? Time period. Time period of the tuning fork prong. The prong is moving up and down. So the prong is moving forward and backward, not up and down, forward and backward. So what time period? Tau is the time period for it. So V, the speed of sound into tau. Correct? In that time only
Yes.
one compression move from this to this place. Correct? Time tau. It will generate time tau. Correct? So in time tau, what distance move? That is what is lambda. What is lambda? V into tau, right? This C1 will change to C2 after one time period, right here? And that time period is mentioned as tau. So here what do we get to see? V plus V naught by V and 1 by tau is nothing but old frequency. This is new frequency. Clear?
Okay.
You can see for yourself, relative velocity did change, lambda remained, lambda didn't change, right? Now I take case 2 quickly. Case 2 is what to me? When observer is at rest and source is moving. Source is moving, okay? Now tell me. Again, after one time period, observation time, one time period. Is it okay? After one time period, where will be C1 over here? C1 will be over here. And tuning fork will be ready to produce another compression. But where is tuning fork? Where will be the another compression? C2. It will be at certain distance. Why? Because tuning fork itself has moved forward by what distance? Vs into tau. Check it out here. In one time period, move distance Vs into tau, correct? Right?
Yes.
So what is the new lambda? This is the new lambda, lambda prime. What is lambda equal to? Lambda is equal to lambda prime plus Vs tau. Check it out. This is lambda, lambda over here. How much is this distance? Vs tau. This also is Vs tau, correct?
Yes.
You can remove tuning fork, it will be all the more clear. Isn't it? Between these two, the distance is Vs tau, correct? Is it okay, Vibha?
Yes, sir.
Clear or not, Vibha? Check once. Between
Yes, sir.
C1 and C2, horizontal distance is how much? Vs tau, correct?
Yes, sir. Thanks.
So lambda is equal to how much? Lambda prime plus Vs tau. Now frequency new, what will it be? V divided by lambda prime. So V divided by what will be lambda prime? Lambda minus Vs tau. What will this be? V divided by V tau minus Vs tau. Which will be V divided by V minus Vs, and 1 by tau will be nothing but old frequency. Correct?
Yes.
With the knowledge of what has taken place over here, you can compound it to acceleration, which is S.C. Verma's last question. That the source is accelerating. Source is accelerating. No problem. When it is moving with constant speed, Vs into tau, right? It is accelerating, then what will it be? It will be changed by half A tau square.
Okay.
Alright, it will be changed by half A tau square, right? That will be the distance. So, same, only Vs tau will be changed to half A tau square. We can use Doppler effect equation if and only if is constant, otherwise we cannot.
What is constant?
Sir is still there?
I think he's there still.
Huh?
I think he's still there.
And there's another field over here, another video.
Mm. 1 minute. I think he's left.
Now he is officially left. Like that.